Hi. So let us start off with the presentation on elements and compounds. As I explained in the intro video, it's a fun topic, elements and compounds. But the most important thing is it is one of the most basic and most fundamentals of the subjects in chemistry. Because chemistry is all about elements and compounds. That's what the chemistry talks about. It talks about how does the elements behave, how do they react to each other. And you can see that all over the place. You look around. Everywhere there is reaction. When you're eating food and when the food goes inside, there are enzymes and acids produced by the stomach, and it is all getting mixed up. And there is a lot of chemical reactions happening inside. And through that, the food which you're taking inside, which are complex carbohydrates, complex proteins, are all broken up into smaller pieces which actually the body can absorb. And that's what is digestion. And that is nothing but a lot of chemical reactions which are going inside your body. So again, you can see it's elements, compounds, and how they react. You look at what is going on as the process of photosynthesis in the plants. Again, it's a chemical reaction which is going inside the plant, which leads to the formation of carbohydrates, which comes out as food and fruits and all that which plants are to offer, and the oxygen which comes out. And so again, there's another chemical reaction which you see on a day-to-day basis. So you can see that, you know, the world around you, you can observe, is filled with various types of chemical reactions, which leads to formation of new substances because of the combination of some other substances and so on. So that is what is going on everywhere. So what I'm saying is that the whole chemistry, I can say, is basically the study of these elements. What are their behaviors? How do they combine? And also study of the compounds. How do they combine and form new compounds? Right? So that is what the chemistry is all about. Right? So we are actually making the first step towards understanding what do you mean by elements, right? And what do you mean by compounds? And for that, we also have to study something called what do you mean by atoms? What are the atoms composed of? How are the molecules formed, right? And so on. So we'll study that in the course of time, as time passes. All right. So that is the very brief introduction about the topic. Let's go ahead and start looking into what is an element. So if you look at it, the definition of element is a pure substance which cannot be broken down into a simpler substance. Right? So let us take something like oxygen, right, which is existing inside in the atmosphere. The oxygen cannot be broken up and into something else. It just can't be broken up. It is a pure substance. Whereas if you look at carbon dioxide, as you've seen in the name of the substance carbon dioxide, you see two things: carbon and oxygen, which basically means there are ways of splitting carbon dioxide to get carbon and oxygen. So it is not an element, it is a compound, right? So elements are pure substances which have not reacted. It is just pure, which contains just itself. The other thing, for example, let's say nitrogen, right? It's again an element. It's pure, right? Whereas if I take a substance called nitrogen dioxide or nitrous oxide, right? You know, these kind of substances, you can see that it's got nitrogen and oxygen, so I can split it to get nitrogen and oxygen. So that's again a compound. So I hope you understand the differentiation between an element and a compound. So elements are pure substances. Iron, it's pure substance, right? Potassium, gold, silver, all these are pure substances. But as soon as they react with some other element, to form a compound, it is no more a pure substance, it is no more an element, because now the compound has got more than one element inside it, right? So let me kind of explain this a little more, right? So let me just go back here and try to explain this. So let's take blue, right? So now let us say that I write CO2, which is actually the chemical name for carbon dioxide. This is in fact a compound. Why? Because it contains carbon. This is carbon, and it also contains oxygen. Sorry, it also contains oxygen. So the compounds contain multiple elements. Whereas if you take something like oxygen, oxygen doesn't contain anything else. It just contains oxygen, which means it is a pure substance. It's a pure substance. And so and hence it is a element. So the pure substance are elements which have not reacted with anything. So it has not reacted with another element. So it has not reacted with another element. So that is what the key thing is. So compounds are formed when elements react, which means a compound contains more than one element. It's got multiple elements, right? Multiple elements. Now, if I write, let me just clear this. Now, if I write something like this, right? So let me write Na2SO4, right? This is actually a chemical name for a compound called sodium sulfate. It's a compound, sodium sulfate, right? Now, forget about its formula, don't worry about it, but it has got sodium. This is Na is nothing but sodium, right? It has got sulfur. This is sulfur, so this is sodium, and this is sulfur, and the O stands for oxygen. So you can see here again, it's a compound. So this is a compound. Why? Because it has got multiple elements. So the compounds can have 2 or more elements, right? So it depends on what. There can be very complex compounds which got 10 elements in it. That's possible, right? But this is a compound which has got 4 elements in it: sodium, sulfur, and oxygen. Each of them are elements. They cannot be broken down again. Each of them, if you take sodium, it cannot be broken down into anything else. It is just a pure substance. So I hope now you have understood the difference between element and a compound. So element is a pure substance. Alright. So let me just clear this. Alright. So now let me just go back to the presentation. Right, here we are. Now let me probably I need to just show you elements generally. You know, I want to just show you elements. So sorry. So this, what you see here down below, you can see this has got a list of elements. So this has got a list of elements in it. And what is this called? Right? Now this is called a periodic table. Right? So let me just go back here. So this is what is called a periodic table. We just write this. It's called a periodic table. Just clear this once again. It's called a periodic. I don't know why. What's the problem with it? Probably periodic table, right? So this is a periodic table. This is a periodic table, right? Now, now you can see these are all elements. So this is hydrogen, this is lithium, and this is a very, very important. This table is a very, very important table. Let me just write it again. So, periodic table, right? And this is an extremely important table which is always used in chemistry. I will see that you will be using this forever in your life if you are dealing with chemistry, if you have anything to do with chemistry. It's an arrangement of all elements which have been discovered till now, right? So you can see hydrogen, lithium, barium, sodium, magnesium, potassium, calcium, rubidium, I think this is selenium, celsium, barium, and then similarly I think titanium, chromium, manganese, iron, cobalt, nickel, copper, zinc, cadmium, silver, palladium, rhodium, you know, and you can see all this, you know, deuterium, right, and so on, and you can see a lot of this, iridium, you know, mercury, Hg is mercury, right, and then this is gold, Au is gold, right, and then you can see boron, carbon, nitrogen, oxygen, fluorine, neon, right, helium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, you know, gallium, germanium, and so on. So bromine, right? So these are all elements, xenon, and you know, lead, right, fluorine, so and so on. So these are all various elements. So these are all, this is basically having all elements, just a moment, there seems to be some small problem here. Let me try to change this probably to black, medium, black. All elements discovered. All elements discovered, right? So this has got all elements which are discovered till now. So that's basically what it is, right? So then this is what's called a periodic table. And I'm going to come back to this. This is a very good site, in fact, and if you are interested, you can also make use of it later on if you want to understand, right? And this is called webelements.com, and if I click on any of them, right, you can see it will give the properties of the element, right? So which group it belongs to, how many electrons and protons it has got, and what is valency, what are its basic properties, who discovered it, blah blah blah. You know, all these details of each element is there in this. So it's a very good site. I found it to be very useful, called webelements.com. So whenever you want to understand about a periodic table and a space, so this is actually properties of iron, right? And you can see all the details about iron and what is the atomic number. We'll see what all these things are, atomic number and all details. What is its atomic weight, who discovered it, what are some of its properties. All these things you can find, right, and some of the reactions the element can have. So it's a very useful site, webelements.com. If you want to actually understand more on the periodic table and the various elements of the periodic table, please use this website, right? And I'll also be using it in this session over and over again. So that is actually about elements. So I hope you have understood what is element. Element is a pure substance, and there are various elements. And if you want to understand what are the various elements which have been discovered by scientists till now, go and refer to the periodic table. The periodic table has a listing of all the elements which have been discovered till now, and you can use this website which I have showed you, webelements.com, if you want to get details of any specific element. It's a very useful website, I can say. Right now, so elements are pure substances which have not reacted. Right, that's what the elements is. Now, let us look at what are the classification of elements. There are different classifications of elements. Right now, what you're seeing here is a very basic high-level classification. There are also several other classifications of elements, but we are looking at a very basic classification of elements. And the elements can be classified into metals, not metals, metalloids, and noble gases. Right? So what are metals? I'm sure that you're already aware of what metals are, and you can definitely give me examples of some of the metals, don't you? I'm sure you can, right? So you definitely have already got some examples of metals. So iron is a metal, right? Gold is a metal, silver is a metal, right? Copper is a metal. So all these are metals. But if you go back and look at the web elements again. I want to just show you the web elements again. So you can see metals are mostly on the left side. So metals come on the left side. So you can see left from middle towards left. So middle towards left, you can see metal. So all these, you can find metals in the pink side and also some on the blue, right? So things like zinc is a metal, copper is a metal, nickel is a metal, cobalt is a metal, iron is a metal, right? All these are metals. Similarly, here you can see sodium is a metal, potassium is a metal, right? So but generally metals are like zinc, copper, cobalt, iron, all these are metals, chromium, all these are metals, right? So the metals, what are the basic properties of metal? Right? The basic properties of metal is that they are very shiny substances. You look at any other metal, you look at copper, iron, gold, silver, all of them are shiny, right? Why gold and silver is used for making ornaments and so on is because of that shiny property. That's what attracts everybody, right? Now, of course, why the gold is typically used is not only that is shiny, but gold has another thing called it's generally inert, right? So we'll see what that means later on. But it is because of this property that a lot of people like metals. They look very nice. They look very attractive because of the shiny appearance. They are very ductile and malleable. What do you mean by ductile? Ductile means you can heat it and make it into thin sheets or thin rods or strings, right? So you can do all that. You can stretch it and make it small thin threads, right? All this is possible. So they are ductile and malleable. That property is what is called ductile and malleable. Being able to pull it into thin strings or being able to hit it flat into very thin sheets, that is what is ductility and malleability, right? And metals are typically very ductile and malleable. They are not brittle. If you take something like carbon, which is not a metal, right? If I hit the carbon, it will break it into pieces. It's very brittle, right? So it's not ductile and malleable. So that is what is the example of metals which is ductile and malleable. They are very good conductors. I'm sure that already you know that, right? You know that if you look at electricity, the electric wires which are there inside your house through which the electricity flows onto your bulb and into your fan and all that, they're all copper wires. So inside that, inside the rubber or the plastic coating which is there, if you look at inside, you can see copper wires. Why? Copper is a very good conductor of electricity. Similarly, a good conductor of heat. I'm sure that you will discuss about that in the heat chapter in physics, right? And you found that these metals are very good conductors of heat, right? So that is why most of the cooking vessels are made using metals like copper or iron or steel. Steel is actually a form of iron. So They are good conductors of heat, good conductors of electricity, very ductile and malleable, very shiny in appearance, very hard and solid, right? Very hard. Why the steel is used for making frames for buildings? You've seen that, I don't know whether you've seen concreting. Have you seen, anybody of you seen concreting? That's the way the roofs are made. And when the concreting is done, first what they do is they put steel frames. And inside the steel frames, they put cement. That's what they do. So in fact, what is really holding the roof is actually these steel frames, which actually gets covered by the cement later on, so you don't see that. But if you are able to cut it and chop it and see inside the roof, you can see that it has got steel frames. And why steel is used is because they are very strong, extremely strong and hard. So it's not going to break easily. And that is why, because typically these days buildings are multi-storied. So you create one floor and then you have the roof, and on that you put another floor. And all the load of almaras and tables and all sorts of things that you put on the floor, right? That load is going on to that concrete. And that load is held by the steel frames inside the concrete. And why steel is used is because they're very, very strong, right? So, sonorous. Sonorous means, it gives a ting sound. If you hit metals, it'll give a ting sound. Have you seen that? Ting. And it stays for some time. If I hit a metal, you say ting. It stays for some time. It sustains. That is what is called sonorous. And only metals have that property. If you look at all the non-metals and metalloids, they don't have the property of being sonorous, right? So metals are having these kind of characteristics, and that's why we classify these elements as metals. Whereas if you look at non-metals like oxygen, nitrogen, sulfur, carbon, all these are non-metals. They don't have these properties. They are not shiny in appearance, right? They are not good conductors of heat and electricity. They are not ductile and malleable. They are very brittle. In fact, if you look at sulfur, right? Sulfur is like powder. It's like a powder, right? You cannot can I make a sheet out of powder? No, I cannot. I cannot make a sheet out of powder. It will just break down into smaller pieces. That's what will happen. Look at carbon. I don't know. Have you seen coal? Have you seen coal? I am sure some of you might have seen coal. Coal is used, in many places like Calcutta and all that. Coal is used for cooking, right? People use coal to cook. Coal probably, I don't know, some of you might have, I don't know whether you've seen barbecues, right? In barbecues, people use coal to make that fire, right? So coal is a good fuel, in fact. And coal is nothing but carbon, right? And have you seen coal? I don't know, if you've taken coal and try to heat it, you'll see that if you hit it, it'll break it into small pieces because it's very brittle. So I cannot, hit the coal and make a sheet out of it or a thin thread out of it and so on. So it's not ductile and malleable, whereas it is very fragile. It is very fragile. I would probably like to write it here. So it is very fragile. Fragile, right? So it's very fragile. So it's not ductile and marble. It's very fragile, right? It's not sonorous. It doesn't produce a ting sound. If you take a pen or a pencil and hit on a metal, a steel glass, you'll get a ting. But you will not get that in the case of a carbon or a sulfur or anything. They are not sonorous. Right? So you can see the differences. They are drastically different in their properties, in their characteristics. The metals and the non-metals are drastically different, way apart in their behavior. Right? So that is a very, very, very important point that I would like to make. So whereas there is also something called metalloids. Right? There is something called metalloids. Now metalloids are some things which are neither metals nor non-metals, right? They are somewhere in between. There are some properties of metals and there are some properties of non-metals. And examples are things like silicon, germanium, boron. All these are elements which are metalloids. Their properties and characteristics are somewhere between metals and non-metals. And in fact, silicon and germanium are two things which are very much used in electronics. I'm sure you have heard about it, right? Silicon is a very, very important element which is used for making the processors inside your computer. I'm sure you have heard about CPU, Central Processing Unit. And the Central Processing Unit has got something called a motherboard. And motherboard has got a processor. There are different processors like Intel processors, AMD processors, right? And all these processors can do a lot of computing very quickly. And these processors are in fact made out of silicon. Right? So silicon and germanium are two elements which are metalloids, which are very, very important in electronics, and it's being used for making various components in electronics. Right? So that's about metalloids. And then there's something called noble gases. Why are they noble gases? If you look at metals and non-metals like copper or iron or gold or silver, all these elements and things like oxygen and nitrogen and hydrogen and all these things, right? If you keep them, what happens to them is, if you take copper and you put it out in the atmosphere for some time, what will happen is after some time you'll see that the copper slowly some kind of a gray coating comes on it. Why that gray coating is coming is because copper is reacting with some of the gases in the atmosphere, and because of it some compounds are being produced, and the compounds are forming as a coating on the copper surface, and because of which that glows, the shininess of copper will go down. Right? Similarly, if you look at iron, don't you see that the iron rods rusting? Right? After some time you'll see rust on the iron rods. Why is that rust there? Why is that rust there? The rust is there because iron is reacting with gases in the atmosphere, and because of which certain chemicals are being formed, and that chemicals are seen as rust. Right? What those chemicals are, we will discover that later. Let us have some fun. Let us have some suspense, right? Let us not jump into everything in one shot. We have both things coming on your way, right? But what you can understand is that rusting is really a chemical reaction happening, and because of it some new compounds being created, and that's what you see as rust, right? So, and similarly, if you look at oxygen in the atmosphere, it reacts with carbon to produce carbon dioxide during combustion, right? None of this. If you look at nitrogen, it can create nitrous oxide and ammonia and various different compounds. So none of all these elements usually will not stay just like that. It will typically react with other things and forms compounds. Whereas if you look at the noble gases, so that is what the thing is. All this, right? Let me just write it down. All these metals and non-metals, they react. They react to form compounds, right? So they react to form compounds, whereas these are noble gases. They do not react with anything. They are also called inert gases. They are also called inert gases, right? Inert means they don't react. That's what inert means, right? So if you look at metals, non-metals, even metalloids, even this belongs to the category of reacting. In fact, these also will react. Metalloids also react. Metals react. Non-metals react. But the noble gases do not react. They never form compounds. They just stay pure as is, right? So that's why they are also called inert gases. Inert gases. Now, why are they inert and why they are noble? That is related to, the atomic structure they have. And that is something that we'll discover later. Don't worry about it. Why they are noble. It is related to the atomic structure. That's one thing which I want to tell you. But why, what do you mean by atomic structure? What is so special about them? Wait. We'll learn it later on. Give it some time, right? Alright, so that is about noble gases. So we have seen classification of elements. You have metals, non-metals, metalloids, and noble gases, right? So I hope you understood what all this means. let us go forward. So that's about elements. Sorry. Now let us look at atoms and molecules. What about atoms and molecules? So we have seen elements. You understood what are elements, right? Elements are made of atoms. Atoms. Atoms are the smallest, smallest particle inside, which is possible. We cannot break the atom again into pieces. It's the smallest particle which is possible, right? So atoms are the smallest particle of an element. So if you look at any element like oxygen or nitrogen, they are all inside the oxygen and nitrogen. There are a lot of atoms of oxygen and nitrogen. So if I take one balloon and fill it with oxygen, assume, right? Now that balloon is full of oxygen gas. And if I look at inside the oxygen gas, what it has is millions and millions of atoms of oxygen. So that is the smallest particle inside that. And these atoms cannot be broken down again into smaller pieces. So they are the smallest possible particle of that element. Right? So that is what I want to make you understand. So atoms are the smallest particle of an element. Right? Whereas what is a molecule? What's a molecule? Now, molecule is formed when atoms come together. And when the atoms, when you say atoms comes together, they may be atoms of the same element, or they may be atoms of different elements. And if they are atoms of different elements, then it's a molecule of a compound. Now let me try to explain this, right? So let me go back to the screen. All right. So now let us say O2. This is in fact a representation of a oxygen molecule. This is a representation of an oxygen molecule. And this 2 means that this molecule has 2 atoms. It's got 2 atoms of oxygen. That's what it means. It's got 2 atoms of oxygen. So, which basically means a molecule has been formed when 2 atoms of oxygen came together. So, it's a group of atoms. A molecule is a group of atoms. So, when 2 atoms of oxygen came together, that formed an oxygen molecule. You got it? Did you understand? Now, let us look at another example. Now, in this case, the molecule has multiple elements. CO2, right? Now, this is actually a molecule of carbon dioxide. It has got one atom of carbon, which is an element, right? And 2 atoms of oxygen. 2 atoms of oxygen. So, which basically means one molecule, and this is one molecule, and this represents one molecule of carbon dioxide. So this represents one molecule of carbon dioxide. So you can see here one carbon atom and 2 oxygen atoms came together, because of which a molecule of carbon dioxide was formed. So here is an example of a molecule which has got multiple elements. Whereas you saw the last example where you had a molecule of just one element, which is oxygen. So all these are possible, right? So you can have molecules which are group of another example is let me tell you another example, right? So another example is P4. P4 is basically a molecule of phosphorus. Molecule of phosphorus, which is another element, phosphorus. And if you look at this molecule of phosphorus, it has got 4 atoms of phosphorus. 4 atoms which are present inside it. Another example of a molecule which has got only atoms of the same element, right? So that would be a molecule of that element. Whereas the if you look at what we saw in the sorry. So if you look at here, you are talking about molecule of a compound, whereas here you are talking about molecule of a element. That's the difference. Okay, so this is a molecule of a compound because it's got multiple elements in it, whereas this is a molecule of a element because it doesn't have multiple elements. It's got only element of a it has got only atoms of a specific element, right? So that is the difference. So here you have atoms of different elements coming together to form a molecule, in which case it's a molecule of a compound, and here the compound is carbon dioxide, right? Whereas here in this case you are talking about a molecule of an element because it's got atoms only of that element. So it's not a compound. Compound means you have multiple elements coming together, right? So that's what I want you to understand. All right. So I hope you got the idea, right? And so let me just clear this and go back to the presentation. So so that is actually about elements and molecules, atoms and molecules. Right? So I hope you understood the atom. So if you look at the atom per se, just if I say one oxygen, this is an oxygen atom, right? So if I say this is an oxygen atom, right? This is oxygen atom. Whereas if I say O2, this is an oxygen molecule. Alright, so that's what I want you to keep in mind. Alright. Okay, fine. So let us just go back to the presentation again. So here we go. So I think you have understood the difference between molecules and elements. So molecules and atoms. So atoms is the smallest particle which is present in an element, and the atoms can come together to form molecules. The molecules formed could be of an element, in which case you are talking about molecules which has got the atoms of only one specific element, like P4 we saw, right, which is a phosphorus molecule, and O2 which is an oxygen molecule where 2 atoms of oxygen is there, and phosphorus P4, that's got 4 atoms of phosphorus. Then we looked at the next example where we looked at the atoms of different elements coming together to form a group, and that is basically again a molecule, but it is molecule of a compound, like we looked at carbon dioxide. I hope that actually gave clarity on what is molecules and atoms. So let us look at this. So when similar kinds of atoms combine, they form molecule of an element, right? O2, P4, all these were examples. Similar, then dissimilar atoms combined. That means elements or atoms of different elements combined, they form molecules of a compound, like CO2 is an example. Carbon dioxide. There was element of atom of carbon and 2 atoms of oxygen came together, and it actually came together to form a molecule of carbon dioxide, right? So that is basically what I want you to understand. All right. Okay. So let us go back into presentation mode. All right. Now, what is the structure of an atom? Now, before talking about John Dalton's theory, I want to just touch upon what Indians have done in this field. Was this concept of atom just put forward by John Dalton, right, and nobody else knew about a concept of it? No, that's not true. In fact, Rishi Kashyapa, right, is the first person. He was later on called as Kanada, right? Rishi Kanada. He was the first person who has in our literature, which was probably in 300 BC, probably, where he has written down about the concept of Paramanu. Paramanu is again the same concept of an atom. What he's saying is every padartha is substance. Every padartha is composed of the smallest particle called Paramanu, which cannot be again divided. Right? He has also spoken about molecules. There could be things like Dvayanu. Dvayanu means two Paramanus come together and combine to form a molecule. And that is what Dvayanu, a biatomic molecule. Now it's called a biatomic molecule. Like oxygen is an example. O2. It has got two atoms of oxygen coming together. So it's a biatomic. Bi means two. Biatomic molecule. Right? So it has got two atoms coming together to form a molecule, and that concept also is something which Kanada has already written in his literature in Dvayanu. It's a great idea if you want to go and look at Wikipedia and or search on Paramanu. You will find a lot of material about what Kanada has spoken about Paramanu. Right? So what I want to tell you is again another instance where already this concept of atom. But you should understand one thing. Of course, even John Dalton, when he proposed this, it was only a hypothesis. What do you mean by hypothesis? Hypothesis is a proposal without proof, right? It doesn't have a proof. In fact, we don't have a experimental proof on existence of something, but it is basically a logical reasoning saying that this should be something which is existing, right? Based on some of the things I see, probably atom should be something which exists inside a substance, and that is what John Dalton proposed. Right? And the same proposal is something which Kanada had put forward pretty long time back, maybe 2000 years, more than 2000 years back. Right? So I want to tell you that again, some thought process which has gone in our Indian scientific community probably a few thousand years back, which is similar to what John Dalton proposed. So in fact, even there were some Greek philosophers who came far after Kanada, in fact, who also proposed the notion of atom. I don't remember their names, but if you want, you can actually go and look at the history of discovery of atom, and you can find the names of those Greek people also. But Kanada is definitely somebody who we as Indians should not forget about, right? Okay. Now let us look at what John Dalton proposed. John Dalton proposed that matter contains atoms. Matter contains atoms. Matter is anything. Anything contains atoms inside, and atoms are the smallest particles which cannot be divided again. I cannot split the atoms again. Yeah, I agree. But later on, we figured out that atoms can still be split, and there are more particles inside those atoms. But still, as soon as we split the atom, when you pull out the electrons and protons out of it, then that becomes atoms of a different element, right? So that is another aspect. We will actually get into that later on when we discuss about atomic structure. But what I want to tell you is that the atom is the smallest particle of an element which has got all characteristics of that element. What is the characteristic? What is it? How does it? Physical state, chemical state, blah blah. All those are characteristics of that element, right? So that atom will have all that characteristic of that element. If I divide the atom, split it, take it, make it, break it and all that, then that characteristic is lost. So that means it's no more the atom of that element. So that is why the atoms is the smallest particle of the element which cannot be split again, right? Which cannot be cracked or separated or whatever, right? All atoms of a particular element has a specific ID. It's got a specific identical size, atomic size, which basically means how many. We'll discuss that. Atomic size, what is atomic number. It has got a specific mass. It has got a specific chemical properties, right? So all the atoms, if you take all atoms, so as I told you, in a balloon, I fill it with oxygen. And that balloon now will have millions and trillions of atoms of oxygen. And each atom of the oxygen will be identical. It will have the same mass. It will have the same chemical properties. It will have the same atomic number. Now you'll kind of, I'm sure they'll have a questioning phase in front of me. what is this guy talking about atomic number? I have not heard about it. What the heck is that? I will explain that. Wait. It will have the same mass. It will have the same mass number. What is this mass number? What is this mass? What is he talking about? Wait. It is coming. I'm going to explain that. So all these characteristics of all those trillions of atoms which is existing inside that balloon is going to be exactly the same. No difference. All atoms will have the same properties, will have same chemical properties, will have same mass, will have same atomic number, will have same mass number, everything same. So all the atoms of an element will be exactly identical. And this, if I take this atom which is in India and oxygen atom in India, and I take an oxygen atom in Australia and an oxygen atom in Africa, same, no difference. The atoms of the element doesn't care where it exists. If that atom is existing in Mars, planet Mars, or if it is existing in planet Venus, or it is existing inside Sun, no difference. It is exactly the same. You understood? So the atoms of the element, doesn't matter where it exists, is exactly identical. No difference. Right? Very, very important. So that is very good actually for scientists, in fact, because if I know the properties of an element, oxygen in Earth, I know then how it behaves wherever else. Right? So that's very useful, in fact, that particular aspect of nature. Right? All this we are talking about is about nature, don't you think so? So science is, as I told you in the beginning, is discovery of nature and trying to explain nature, right? So you are all nature discoverers when you become scientists. All right. So now let us look at the next slide, right? Which talks about internals of an atom. Now, before jumping into the slide, I want to probably take you to a website and show you a diagram of what is the atomic structure. So this actually in fact shows the structure of an atom, right? So this is actually in fact structure of a carbon atom. Now the carbon atom, so now before getting into the numbers and all that, I want to tell you that an atom can have 3 types of particles inside it. It will have protons, neutrons and electrons, right? So these are the different types of particles which an atom can have: electrons, protons and neutrons. Now before delving into this, I want to explain to you about what do you mean by electric charge. Electric charge. Now, before talking about electric charge, I want to, because since you have not learned electricity probably till now, I don't know, some of you might have learned. In that case, you know what electric charge is, right? But if you don't know, I want to relate it to magnetism, because that's something that you've learned already. Now, you know that in magnets you can have, North Pole and South Pole. Right? You can have North Pole and South Pole. So you can have North Pole and South Pole. Right? So the magnets can have North Pole and South Pole. You agree? And the North Pole and South Pole attract each other. Right? They attract each other. Whereas if you have North Pole, just a moment.